Good evening, dear students. Yes. Okay, fine. So, in the previous class, we were discussing about aldehyde ketones and carboxylic acid. So, we have completed the MCQs, right? So, we have completed these MCQs. So, you know, this particular chapter is for 14 marks, right? So I told you that some applicative type of questions I'll be solving in the next class. So we have seen the type of questions that is asked from this particular chapter, right? So these were the questions which we have seen. So please go through the name reaction which all we have studied. So addition of hydrogen cyanide to aldehyde and ketone. So this particular question is for 3 marks, right? So the named reactions, so very important named reactions. So these are the named reactions which we have seen. Stephen reaction, Ithard reaction, then Rosenmund reaction, right? Uh, then Wolff-Kishner reduction, Clemmensen reduction, Tollens test, Fellings test, right? Cannizzaro reaction, Hell-Volhard, Zelinsky reaction. So these all things we have seen, right? So these are the direct questions which we have seen. So today we are going to see some of the questions which are applicative type of questions. Okay. So these are the questions. Okay. So we'll start uh, to answer these questions. So how the questions are asked. Okay. So this is the first question. Explain Rosenmund reduction. Give an example. Okay. So this is one question. How it will be asked. So define Rosenmund reduction. Give an example. Or the type of question, explain Rosenmund reduction of benzoyl chloride. Okay, so the starting reactant given is benzoyl chloride. Or the question is asked as how benzoyl chloride is converted to benzaldehyde. Write equation and name the reaction. Okay, so this particular question is asked for 3 marks. Okay, so like this question is asked for 3 marks. So for explaining the Rosenmund reduction, okay, with the your general reaction, 2 marks, and with the example, you have to, so that will be for 1 mark. Okay, so completely this question is for 3 marks. So like this, the stepwise, how the question is divided. Okay, stepwise, the marks are given. Fine. So Rosenmund reduction. Yes. Can you tell me what is Rosenmund reduction? Yes. So, okay. So what is the answer expected here to answer? Okay. Explain Rosenmund reduction. Give an example. Explain Rosenmund reduction of benzoyl chloride. Okay. Or how benzoyl chloride is converted to benzaldehyde. So write equation and name the reaction. Right. So acid chloride is hydrogenated over palladium on barium sulfate to give aldehyde. Okay. So this reaction is called as Rosenmund reaction. Okay. Sorry, reduction. Fine. So what is the expected sentence? Okay, explanation you need to write. So acid chloride is hydrogenated. What do you mean by hydrogenated? We are adding up a hydrogen. Okay, reduction is nothing but addition of hydrogen, right? So when we are adding hydrogen, fine. So what we are doing here, right? So acid chloride. So we'll write the reaction now. So acid chloride, so if I write the general reaction, it is ROCl. Okay, acid chloride. So we are doing hydrogenation. Okay, that is we are adding hydrogen in the presence of palladium and barium sulfate. So this your acid chloride is converted into aldehyde. The acid chloride is converted into aldehyde. So this is the general reaction. Okay, expected what uh, your acid chloride. Okay, so this is like expected. So this is expected. Okay, so this thing you have to write there. Now, so if a general reaction, so what general reaction? So I can take your R. So I will take this R as benzoyl chloride. Okay, I'll take a benzene ring. So if I take this as benzene ring, Okay, so this is a benzyl chloride. So benzyl chloride in the presence of hydrogen and palladium and barium sulfate. Okay, so this is undergoing reduction. So uh this okay acyl group is converted into aldehydic group. Okay, that is C double bond O. So it undergoes what? It undergoes reduction. Okay, it undergoes reduction. So this is the expected answer. Okay, so this is the expected answer. Understood? Yes. So this is to be answered. Okay, so like this, the question can be asked. So this is a bit twist, right? So this, you can see this particular question, just a second here. How benzoyl chloride is converted to benzaldehyde. Okay, so here it is not mentioned that explain Rosenmund reduction. So here they have given the molecules. Okay, how benzoyl chloride can be converted to benzaldehyde. So write the equation and name the reaction. So you have to write this what equation? Okay, of conversion of this benzoyl chloride to benzaldehyde. Okay, so for the explanation, for the equation, and for the name of the reaction, you get 3 marks. Okay. So this is the expected answer. Fine. Now, next one is, so moving further, next question. How do, just a second, how do you prepare acetaldehyde from acetyl chloride? Name the reaction. Yes, can you name the reaction, students? How do you prepare acetaldehyde from acetyl chloride? Name the reaction. Yes, can you name this particular reaction, students? You can use the chat box for answering. Yes, yes. How do you prepare acetaldehyde from acetyl chloride? Can you name the reaction? You can use the chat box to answer. Okay. So, yes, you can use the chat box. Fine. Nobody knows. Okay. How do you prepare acetaldehyde? Okay. So what is the structure of acetaldehyde? So acetaldehyde is CH3 C double bond O. Okay. So this is your acetaldehyde. Okay. C double bond O H. So this is acetaldehyde. Okay. So acetaldehyde. So how do you can, and what is acetyl chloride? So acetyl chloride is what we are taking instead of R. Okay. In the previous, our just a second, you can see, I can get back my equation. Okay, here you can see, yes, here you can see, students. Okay, here you can see. So this is your one acid chloride. Okay, here you can see here. Okay, so here I have taken for the previous question, I have taken my R as a benzene ring, right? I have taken a benzene ring. Now here if I take R is equals to CH3. Okay, here if I take R is equals to CH3. So this is what CH3, C double bond O, Cl. Okay, so this is your acetyl chloride. So this is your acetyl chloride. So acetyl chloride in the presence of H2, okay, palladium and barium sulfate, you get what? You get acetaldehyde. You get acetaldehyde plus HCl. Okay. So what is the name of this reaction? Yes, where you are converting a acetaldehyde to, sorry, acetyl chloride to acetaldehyde. It is a Rosenmund reduction. It is what? It is a Rosenmund reduction. Yes, is it right? Is it clear, students? Is it clear? Moving further, next question. Explain stiffened reaction. Give an example. Or, okay, so this is a direct question. Explain stiffened reaction. Give an example. Or a twisted way of asking this particular question is, how is propane nitrile converted to propanol? Right equation. Okay. So how is propane nitrile converted to propanol? Okay, right equation. Now, okay. Now how to answer this? How to answer this now? So stiffened reaction. Okay, you know that what is stiffened reaction? Nitriles on reduction with stannous chloride. Okay, what we are doing? We are taking nitriles. Okay, we are taking nitriles. Okay, we are doing reduction here. Okay, so what we are doing? Reduction in the presence of stannous chloride and hydrochloric acid. Okay, and hydrochloric acid, it gives you what? It gives you imines. It gives you imines. Okay, so that is your triple bond is converted into double bond. Fine. So across the triple bond, one bond is broken and we are adding hydrogen. So your nitrile is converted into imines. Okay, nitrile is converted into imines. So this on further undergoing acid hydrolysis, it undergoes acid hydrolysis to give you aldehyde. Okay, it gives you what? Aldehyde plus ammonia. It gives you aldehyde plus ammonia. It gives you aldehyde and ammonia. Okay, so this is the expected for. Yes, so this is the expectation. This answer is expected for your explain Stephen reaction. Okay, and give one example. So what example you can give your? Okay, I can take my this. Okay, I'll take this as R is equals to a propane group. Okay, if I take R is equals to a propane group. Okay, so how it will be? So this will be CH3, CH2. Okay, then C triple bond N plus H2 in the presence of tin chloride plus hydrochloric acid. So it is converted to CH3, CH2, CH, double bond NH. So this further undergoes hydrolysis to give you what? CH3, CH2, CHO plus NH3. So what we have done, we have taken a propane nitrile. Okay, we have taken a propane nitrile and this propane nitrile is converted into a imine. Okay, it is converted, the intermediate is imine. Okay, and the product is propanol. Okay, it is converted into a aldehyde. Okay, it is converted into a aldehyde. Is it clear? Is it clear, students? Yes, any doubts still here? So, we are solving, okay. So, we are solving the direct question also and indirect question. Okay, so please remember, okay, how it can be asked. So, here how it is asked, see, how is propanol converted to, how is propane nitrile converted to propanol? Okay, write equation. So, you have to write this equation of propanaldehyde. Okay, so this particular equation is expected there like this. Okay, propanitrile in the presence of tin chloride and hydrochloric acid give you the imine. This further undergoes acid hydrolysis to give you propanol. So this is a stiffen reaction. This is what reaction? It is a stiffen reaction. Okay, fine. Moving forward, next question. What is Itard reaction? Write the chemical equation. Okay, what is Itard reaction, students? What is Itard reaction? What is expected? So Itard reaction is what? Toluene. Okay, we take the starting product as toluene. Okay, what is the toluene? This it is like this CH3. Okay, toluene. So toluene. Just a sec. Okay, so toluene. Okay, so what happens to toluene? So toluene reacts with chromyl chloride. Okay, what is chromyl chloride? CrO2Cl2. Okay, so toluene reacts with chromyl chloride in the presence of carbon disulfide. Okay, in the presence of carbon disulfide, and it gives you a complex. It gives you what? It gives you a chromium complex, that is CH. Okay, and OCrO HCl2. Okay, it gives you a chromium complex, and this further undergoes acid hydrolysis. It undergoes what? Acid hydrolysis to give you, so this is a chromium complex. So what the intermediate is form is a chromium complex. Okay, so our toluene. Okay, what is happening here? Our toluene in the presence of chromyl chloride. So chromyl chloride, and the solvent used here, a polar solvent, that is carbon disulfide. Okay, it forms a chromium complex, so undergoes a acid hydrolysis. Okay, and further this complex is converted into a aldehyde. Is converted into a aldehyde. So the resulting product is benzaldehyde. So the resulting product is what? Benzaldehyde. So which is the resulting product? It is a benzaldehyde. So this is a Itard reaction. So what is happening in Itard reaction? Toluene is converted into a benzaldehyde. So it is undergoing a oxidation reaction. Okay, it is undergoing a oxidation chromyl chloride. Okay, so toluene. So toluene in the presence of chromyl chloride, it gives you what? It gives you a chromium complex which undergoes acid hydrolysis to give you benzaldehyde. Fine. Okay. Or the other way of asking the question is, so how the other question can be asked in other way? Okay. So the question asked in other ways, how do you prepare benzaldehyde from toluene? Okay. How do you prepare benzaldehyde from toluene? So how benzaldehyde is, so you can see this equation. Okay. And that is toluene by Ithard reaction, write the equation. Okay. So benzaldehyde is prepared from toluene by reacting the toluene with chromyl chloride in the presence of carbon disulfide. It further forms a chromium complex, further undergoes acid hydrolysis to give you benzaldehyde. So this is the explanation that is expected. Okay. And the equation, and you have to write the uh, equation. Okay. So this is the particular reaction. Is it clear? So we have seen 4 questions till now. Is it clear till here, students? Use your chat box. If you have any doubts, you can use your chat box. So there you can ask you any doubts, or if you have understood, please tell me there. Yes, so we have seen 4 questions. Okay, so moving forward, the fifth question, write equation for Gatterman-Koch reaction to convert benzene to benzaldehyde. Okay, so we are seeing the Gatterman-Koch reaction. So what is Gatterman-Koch reaction? So Gatterman-Koch reaction is your benzene. Okay, so we are converting the benzene to benzaldehyde. So how we are converting the benzene to benzaldehyde? So this is our benzene. The reagent uses carbon monoxide in the presence of hydrochloric acid. Carbon monoxide in the presence of hydrochloric acid. Okay. And we are making use of Lewis acids like anhydrous AlCl3 or cuprous chloride. Okay. And by this reagent, we are converting our benzene to what? Benzaldehyde. So we are converting our benzene to benzaldehyde. So this is a Gattermann equation. So what we are doing in Gattermann-Koch reaction, we are converting our benzene to benzaldehyde. So which is the reagents which we are making use of? We are making use of carbon monoxide in the presence of hydrochloric acid. Okay. And anhydrous AlCl3 or cuprous chloride. Okay, so by using this reagent, we are converting the benzene to benzaldehyde. Okay, so this is a Gattermann-Koch reaction wherein we are converting the benzene to benzaldehyde. Okay, so how this question is asked in the other way. Okay, so this particular question can be asked in other way as benzene reacts with carbon monoxide and dry HCl in the presence of anhydrous AlCl3. Write the structure of the product and name the reaction. So they have asked you what is the structure of the product. So what is the product obtained? It is benzaldehyde. So that structure you have to write of the benzaldehyde. And what is the name of the reaction? The name of the reaction is Gattermann-Koch reaction. Okay. So a small explanation, the product name, okay, the structure of the product and the name of the reaction. So this particular question is also for 3 marks. Okay. So like this, the question is twisted. Slightly it is twisted. Okay. Fine. Moving forward. Next question. Sixth question. Okay, we are into sixth question now. Explain the preparation of ketone from acid chloride and dialkyl cadmium, or name the product obtained by the reaction of acetyl chloride with dimethyl cadmium. Write equation. Okay, how do you expect this now, students? Yes, how do you expect the answer for this? So here the expected answer is what? So they have asked you explain the preparation of ketone from acid chlorides and dialkyl cadmium. Okay. So the general reaction, it can be written as this 2R dash, okay, COCl. So this is our acid chlorides. Okay. So this is our acid chloride, that is 2, okay, C double bond O Cl. So this is acid chloride. So acid chloride, it reacts with dialkyl cadmium. So dialkyl cadmium, okay, and it gives you what? It gives you a ketone, that is uh 2R dash C double bond O and R. Okay, so you get a ketone plus cadmium chloride. You get cadmium chloride. So this is the reaction. So explain the preparation of ketone from acid chloride and cadmium. So this reaction you have to explain. Okay. Now what is the explanation for this? So your 2 moles of acid chloride reacts with dialkyl cadmium, okay, to give you ketone as the product and cadmium chloride as the byproduct. Okay, so name the product which is obtained by the reaction of acetyl chloride and dimethyl cadmium. So what they have taken now? They have taken acetyl chloride. So R can be your CH3, C double bond O, Cl. Okay. So I've taken the so our R is what? So our so this is our R. Okay, R is our acetyl chloride. So I have taken acetyl chloride, 2 moles of acetyl chloride. So reacts with what? Dimethyl cadmium. So I take CH3 twice. Okay, CH3 twice and CD. So dialkyl cadmium. Okay. So what is the expected product? So the product is 2CH3 C double bond O CH3 plus cadmium chloride. So what is the product name? Can you tell me the product name, students? Yes, what is the product name? What is the product name? Can anyone tell me what is the product name? Yes, can anybody tell what is the product name? The name of the product is acetone, right? The name of the product is acetone. Okay. The name of the product is acetone. Fine. Okay. So this is the particular answer. Moving forward. So next question. How does benzene react with acetyl chloride in the presence of anhydrous AlCl3? Give equation. Yes, how does benzene reacts with acetyl chloride? So how do you write this equation? Can you give me the product obtained? Yes, please answer. Are you understanding the things or no? Yes, so we'll write the benzene structure. So benzene, this is the structure of benzene. So what is expected here? So benzene is reacting with acetyl chloride. So CH3, C double bond O, Cl. So this is our acetyl chloride. Okay, in the presence of what? Anhydrous AlCl3. Okay, can you give me the equation? Okay, let me see who will tell me the product name. Tell me the product name. Okay, Vedvati has answered. Okay, let others also answer, then I'll tell. Okay, so Vedvati has answered it as acetophenone. Is it right? Is it correct, students? Acetophenone. So, when benzene is reacting with acetyl chloride in the presence of anhydrous AlCl3. So, benzene, okay, so this is our benzene, and this particular group gets attached here. So, that is C double bond O CH3, okay, plus HCl. Yes, so this is acetophenone. Okay, so the answer is correct. Acetophenone is the product which is obtained when benzene reacts with acetyl chloride in the presence of anhydrous AlCl3. Okay, good. Good, Vedvati. Good. Okay, so we'll go move for the next question. So next question. Ketones are generally less reactive towards nucleophilic addition reactions. Give any two reason. Okay. So can you give me two reasons why ketones are generally less reactive towards nucleophilic addition reaction? So this is a ketones. Okay. So why these are less reactive? Can you tell me? What is the reason? So what are the two reasons you can expect? So this question is asked for 2 marks. Okay. So two reasons, 2 marks. Okay. Okay. Yes, Deepak has answered. One point is clear. Due to steric hindrance. Yes, good. Next, one more reason. So you can see, okay, because of the bulkier group, it is so the nucleophile cannot attack the carbonyl carbon because this R and R dash can be bulky groups. Okay, so they can be suppose if I take both as a phenyl group. Okay, both as the your benzene groups. Okay, so the attack is not possible because it is both are the bulky groups. So first reason is, so generally the ketones, they are less reactive towards a nucleophilic substitute addition reaction. Okay, so first reason is correct, that is due to steric hindrance of bulky group. Second is what can be the second reason? Yes, students, what can be the second reason? It can be due to electronic effect. Okay. What is electronic effect? So whenever the compound has double bond, okay, whenever the reagent, okay, so suppose I have so what we are expecting here, ketones. Okay, so if I take CH3, C double bond O, and one bulkier group here. Okay, so when I do the addition of okay, I take OH group. So this OH, when it tries to attack here, okay. So what will happen here? So electromagnetic effect is nothing but it is a temporary effect, okay, which is produced when a reagent will attack, okay, on the multiple bonded carbon. So what it does, it helps in shifting this pi electron. So there will be shifting of pi electron takes place. So either of the two atoms of the bond. So either the bond can be shifted to either of this atom. So it is so the two reasons are, one is due to steric hindrance of the bulkier groups and second is electronic effect. Okay, so remember these two reasons. Fine. Okay. Next question. Explain aldol condensation with an equation. Aldol condensation with an equation by taking acetaldehyde. Okay. So shall we explain the aldol condensation by taking acetaldehyde? Explain acetaldehyde. So acetaldehyde. Okay. So for aldol condensation, there should be same molecule. Okay. They undergo what do you say? Self-condensation. So there are two same aldehydes will be taken. So that is aldol condensation by taking acid. So I take two molecules of acetaldehyde. Okay. So aldehyde should contain at least one alpha carbon atom. So either of it should have a alpha carbon atom. So it undergoes what? It undergoes self-condensation. It undergoes what? It undergoes self-condensation. So in the presence of any base, so you can take here, they have given dilute NaOH. So I can take dilute NaOH. Okay. Then what happens? There will be loss of the this what water molecule. So it undergoes loss of water molecule and it forms alpha beta unsaturated carbonyl compound. Okay. So the product obtained is CH3COH. So here there will be abstract of proton from here this will attack, and here it forms OH. So COH, then here the group will get attached, that is CH2, C double bond OH. Okay, and this is your H. Fine. So this is your 3 hydroxy. So 1, 2, and 3. So 3-hydroxybutanol. Okay, 2-hydroxybutanol. Fine. So this will undergo what? This, when you heat it, there will be loss of water molecule and it forms butene. That is CH3, CH double bond, CH, CHO. So this is butene. Okay. So in all. Okay. So this is what? This is a alpha beta unsaturated carbonyl compound. So it is forming what? The product obtained is alpha beta unsaturated carbonyl compound. Is it clear? Okay. So here the question is asked in other way also. How it is asked? What is the action of dilute NaOH on ethanol? Okay. What is the action of dilute NaOH on ethanol? So ethanol is nothing but your acetaldehyde. Okay. And they have asked what is the name of the reaction. So name of the reaction and the equation if you write. So this is a 3 marks question. Okay. So, so this is a type of question. It is asked based on your aldol condensation. Next is Carin-Zaro. Explain Carin-Zaro reaction with an example, or write equation for the reaction between formaldehyde and concentrated NaOH. Okay. So what is the product obtained, students? Yes, what is the product obtained? So should I write the reactants? Okay, let me write. So explain Carin-Zaro reaction. So in Carin-Zaro reaction, there will be a aldehyde, okay, which do not contain any alpha hydrogen. So this what? Okay, Vedvati has answered it as sodium format. Okay, alcohol. Fine, I'll see. Okay, so Carin-Zaro reaction, what happens here? So yes, alcohol and a correct. So alcohol and the sodium format. Okay, you have told me the product of it. Yes, good. Fine. So explain Carin-Zaro reaction. So when a aldehyde which do not contain alpha hydrogen, okay, it reacts with the concentrated alkali. You can take a concentrated alkali like sodium hydroxide. So sodium hydroxide is a strong alkali. Okay, so when aldehyde which when you take the aldehyde which do not have alpha hydrogen, okay, and it reacts with concentrated alkali, what it undergoes self oxidation. Okay, and reduction. It undergoes self oxidation as well as reduction. So you will get a carboxylic salt of carboxylic, okay, a carboxylic acid salt and a alcohol. Okay, so let me write the equation. So if I give you equation as CHO, so this is what? So 2 moles of formaldehyde. Okay, so this is formaldehyde. When it reacts with concentrated NaOH, when it reacts with concentrated NaOH, you get what? So one will undergo oxidation and another will undergo reduction. So you get what? Methanol. You get a methanol and sodium formate. So this is a carboxylic salt. Okay, that is sodium formate. Understood? So the other question is asked is write equation for the reaction between formaldehyde and concentrated NaOH. So like this. So the equation is formaldehyde reacts with concentrated NaOH to give you methanol and sodium formate. Okay. Now this sodium formate and methanol. So this equation is a Carin-Zaro reaction. Okay. So this is the way it is asked. Fine. Next question. Next is 11th question. How carboxylic acids are prepared from Grignard reagent? So how does carboxylic acid are prepared from Grignard reagent? Or the question is, write general equation for the formation of carboxylic acid from Grignard reagent. Yes. How do you write this? How carboxylic acids are? What is Grignard reagent? First of all, what are Grignard reagent? Grignard reagents are, yes, RMGX. So these are organometallic compound. These are called as what? Organometallic compound. Okay, that is RMGX. Good. Organometallic compound. So when this Grignard reagent reacts with carbon dioxide, what is carbon dioxide? Carbon dioxide is called as dry ice. Okay, we are making use of dry ice here. Okay, that is solid carbon dioxide. So we are making use of solid carbon dioxide, which is called as dry ice. Okay, and it forms what? It forms in the presence of dry ether. We are taking the reagent as dry ether because whenever we are preparing any compound from Grignard reagent, we are making use of solvent like dry ether. So what you get? You get the product as salt of you get the product of salt. Okay, you get a product of salt of carboxylic acid. You get a product of salt of carboxylic acid. Okay, you will get what? You will get the product of carboxylic acid, that is salt of carboxylic acid. So this salt of carboxylic acid, further it undergoes what? It undergoes acidification. It undergoes acidification to give you carboxylic acid. It gives you carboxylic acid. So this is the general equation for the formation of carboxylic acid from Grignard reagent. So we are taking Grignard reagent, we are reacting with solid carbon dioxide, which is called as what? Solid carbon dioxide is called as dry ice. It is called as dry ice. Okay. The solvent used here is dry ether. It forms a salt of carboxylic acid. Okay. Salt of carboxylic acid. This further undergoes acid hydrolysis. It undergoes acid hydrolysis to give you carboxylic acid. Okay. It gives you carboxylic acid. Okay. So this is the answer which is expected. Fine. Is it clear till here? So we have seen 11 questions till. Okay. Is it clear? Any doubts till here? Yes, students, any doubts? If you have any doubts regarding, uh, okay, the things which we have dealt till now, you can ask me. Okay. Okay. So 12th question. So we'll go for 12th question. Among methanoic and ethanoic acid, which is more acidic and why? Okay. Can you answer this? Among methanoic and ethanoic acid, which is more acidic and why? Okay, I want this answer from you. Among methanoic and ethanoic acid, which is more acidic? So methanoic acid is, okay. Can you tell me between the methanoic and ethanoic acid, between methanoic and ethanoic acid, which is more acidic and why? Yes, students. Yes, try answering this. Yes, I have drawn the structures also. So seeing the structures, at least you can tell. So here, if I so hydrogen C double bond O OH. This is CH3 C double bond to OH. Okay, so this is your methanoic acid. This is your ethanoic acid. Okay, so now, okay. So here, okay. So here, which is more acidic? At least that you can tell me. The reason I'll tell you. Which is more acidic? Methanoic acid or ethanoic acid? Did not understand? Yes, nobody's responding. Did not get the question. See here, they've asked, they've given two structures, okay? That is one compound is methanoic acid, another is ethanoic acid. So I've drawn the structures also for both. Okay, so they have asked now between these two structure, which is more acidic. Okay, so when we see the methanoic acid structure, okay, when we see the methanoic acid structure, okay, you can see that, okay, the hydrogen is directly attached to the carbonyl carbon. Okay, the hydrogen is directly attached to the carbonyl carbon. Okay, because this is a electron donating group. So, so that is hydrogen here, the hydrogen is directly attached to carbonyl carbon. Now, when you are seeing the ethanoic acid, okay, when you are seeing the ethanoic acid, the methyl group. What is methyl group? Methyl group is a electron donating group, right? Electron group is it is a electron donating group. So this electron donating group, it is attached to the carbon atom, okay, which is attached to the carbon atom. So because of this, it will decrease the polarity of the OH bond. So because of this, it will decrease the polarity of the OH bond. Okay. So uh, methanoic acid. So this is more acidic. So when you compare the acidic level, okay, so depending upon the type of groups which is or type of atom which is attached, okay. So your hydrogen is attached to the carbon, okay, which is further attached to the OH group. But here the methyl group, okay, methyl group, which is an electron donating group, is attached to the carbon, okay, which in turn decreases the polarity of OH bond. So methanoic acid is more acidic. So this is the reason it should be written. Okay. You can say so this also so and that is due to plus I effect. Due to plus I effect. So you know what is inductive effect, right? So when you have suppose CH3, CH2, Cl. So because of the that is the electronegative atom, what it will do, it will tend to pull the electron towards itself. So as a result, there will be partial negative, partial positive, your partial positive. So between these two carbon, this will be a bit electronegative because this is directly attached to a electronegative atom. Okay, so the minus effect is more in case of this carbon as compared to this carbon, okay, because it is bit far further. Okay, so this is the reason. Fine. Okay. So here we are seeing the minus I effect. Here because here we are seeing the minus I effect. Okay, here we are seeing the plus I effect because there is a presence of what? Methyl group. Fine. Electron donating group. Okay. Further, further questions. So we are left with two more questions. So we'll solve this and then we'll stop. Fine. What is the action of ammonia on benzoic acid? Write equation. Or the question can be asked as How do you convert benzoic acid to benzamide? Write equation. Or the question is asked in other way as name the product obtained when benzoic acid is heated with ammonia. Okay. So benzoic acid. So let me write the structure of benzoic acids first. So this is a benzoic acid. Yes, students. So this is benzoic acid. So benzoic acid, when it reacts with ammonia, what happens? It gives you ammonium benzoate. It gives you what? It gives you ammonium benzoate. Okay. It gives you ammonium benzoate. So this is the structure of ammonium benzoate. Just a second. Okay. So C double bond O NH4 plus. Okay. So here what is happening? Your hydrogen. Okay. The hydrogen is replaced by your ammonium group here. Okay. So it is forming here ammonium benzoate. Ammonium benzoate. Okay. So this is the intermediate which we get. Okay, so what we are getting here, the hydrogen is replaced by this ammonia. What is happening here? Your hydrogen is replaced by ammonia. So your it is forming a ammonium benzoate. So this ammonium benzoate, when we heat, okay, when we heat, it is converted into a amide. So it is converted into what? It is converted into amide. So there is a formation of amide group. So your ammonia, okay, ammonia gets converted into amide. Okay, so what is a product obtained? It is a benzamide. Okay, the product obtained is a benzamide. Okay, so this is a product which we are getting here. Fine. So see the question how it is asked. What is the action of ammonia on benzoic acid? Write the equation. So this particular equation you have to show. That is, you have to mention the names. So benzoic acid, okay, benzoic acid when it reacts, okay, so benzoic acid when it reacts with ammonia, okay, benzoic acid when it reacts with ammonia, okay, it gives you ammonium benzoate. It gives you what? Ammonium benzoate. So this ammonium benzoate, when we heat, okay, when we heat, we get benzamide. We get benzamide. Okay. So again, how do you convert benzoic acid to benzamide? Right, the equation. So a slight twisted question. Okay. And the next form they have asked is name the product. Name the product which is obtained when benzoic acid is heated with ammonia. So what is the product obtained? It is benzamide. So like this. So the question can be twist in these manner. Okay. So you can see for one particular question. Okay. Sorry, for one particular answer. Okay. So this is the answer. You can see there are three questions. So the way of asking this particular question is three. Okay. We have seen here. So the way they have asked in three different ways, right? Okay. Fine. So this was the question. Okay. So next question. Write equation for the conversion of ethanoic acid to monochloroethanoic acid or explain HVZ reaction with an example. So this is a direct question. Okay, they have asked directly the Helvollard-Zelinsky reaction here. Okay, so you can see here they have directly asked this is a direct question. Okay, here you can see how they have asked conversion of ethanoic acid to monochloroethanoic acid. Okay, so how this should be answered? Yes, how this should be answered. So, how we are converting into monochloroethanoic acid. So, what is your Hell-Volhard-Zelensky reaction? We are taking the starting product. Okay, so we are taking the carboxylic acid, which is having alpha hydrogen. Now, what do you mean by alpha hydrogen? So, next to your this carbonyl carbon. Okay, I'll write it systematically. So, here, see here, C double bond OH. Okay. So next to your carbonyl carbon, you have a alpha hydrogen. So this is a alpha hydrogen. Okay. So carboxylic acid, which is having alpha hydrogen. So next to your carbonyl carbon, you have a alpha hydrogen, right? So this alpha hydrogen, Okay, when you treat your carboxylic acid, which is having a alpha hydrogen with the reagents like you are taking a dihalo compound. Okay, you are taking your either a chlorine or you can take bromine. Okay, in the presence of red phosphorus, we are taking red phosphorus. Okay, and we are treating it with water. We are treating it with water. What is happening here? One of the hydrogen. Okay, one of the hydrogen here. It is what is happening? It is uh, what you can say. One of the hydrogen is uh, replaced, okay, by a halo group. It is replaced by a halo group. So it is called as monohalo, that is monochloroethanoic acid, or it is called as alpha halocarboxylic acid, because at your alpha hydrogen, okay, at your alpha hydrogen you can see that at your alpha hydrogen, one of the hydrogen is replaced by the chlorine group. Okay, one of the hydrogen is replaced by your chlorine group. Fine. So one halo group. So one of the hydrogen is replaced by the halo group. Fine. So this is the Helvolar-Zelinsky reaction. Now, so this was a direct question. So what the explanation should be written? Carboxylic acid having alpha hydrogen when it is treated with chlorine or bromine in the presence of red phosphorus gives you alpha halocarboxylic acid. So this reaction, the name of this reaction is Helvolar-Zelinsky reaction. Okay, so you can take your X as chlorine or bromine. Okay, now if I want to prepare ethanoic acid, so ethanoic acid, ethanoic acid to mono, so ethanoic acid is nothing but your acetic acid. Okay, so acetic acid, so acetic acid, you have to treat it with what? You have to treat it with your X2. So I go to chloro. So I'll take Cl2 in the presence of red phosphorus, treat it with water. Okay, what you get? You get CH2. Okay, one of the hydrogen is replaced by chlorine. Okay, and you get C double bond O OH. Okay, so what it is? It is a monochloro ethanoic acid. Is it clear? Yes. Any doubts? Any doubts? So we have seen. So so from this particular chapter, we have seen like most of the questions we have covered, right? So we have seen the MCQs. Then in the previous session, we have seen the important name reaction, and today we have seen how the direct question is asked as well as the twisted way, how the question can be twisted. Okay, so applicative type. So these are the questions from this particular chapter. So now if you have any doubts regarding the chapter aldehyde, ketones, and carboxylic acid, you can ask me in the chat box. Yes. Any doubts? So we have completed the chapter aldehyde, ketones, and carboxylic acid. Okay. Any doubts in this chapter? If you have any doubts, you can ask me in the chat box. If you don't have, you can. Okay. Others, any doubts in the chapter? So we have left with four more chapters. Okay, that is chemical kinetics, D and F block elements, coordination compounds, and amines. Okay, so we'll be in the next class, we'll be starting with the chapter amines. Okay, so four more chapters. I hope you are studying. So whatever the things have been told, whatever the important things are covered, please go through, please practice. So as I have been telling in the previous classes also, organic chemistry, you need more of practice, okay, for writing the chemical, all the reactions, okay, all the mechanisms, you need practice. So you cannot bahart them, okay. So please write and practice the your name reaction, okay, the mechanisms. So you cannot bahart these. So whatever the important things are told, uh, okay, just go through all the things I hope you're making the points, whatever has been told. Okay. Uh, Fine. So I hope there are no doubts from this particular chapter. Yes, feel free to ask if you have any doubts. You can ask. Okay. So I hope there are no doubts. Hoping that everything is clear. Okay. Fine. So I shall end the session here. So in the next class, we'll be starting with amines. Okay. That is the compounds containing nitrogen. Fine. Okay. So thank you. Thank you, dear students. So we'll meet in the next class.